Hello and welcome to this video tutorial about canonical standard forms in Boolean algebra. First off, we will introduce you to the concept of minterms and maxterms. Say we have a binary variable x. This variable may either appear in its normal form or as x, or in its complemented form or x prime. With this, we could say that n variables have 2 raised to n possible forms. Now let's place this formula here for the future reference. So basically, minterms are variables combined together by an AND operation, and maxterms are variables combined together by an OR operation. Now let's take, for example, two variables x and y and initially combine together using an AND operation. Since there are 2 variables, which means n is equals to 2, then 2 raised to 2 is equals to 4, meaning we have 4 possible forms of xy, namely xy, x prime y, x y prime, and x prime y prime. These 4 possible forms of xy are called minterms. So that's minterms xy, minterm x prime y, minterm x y prime, and minterm x prime y prime. But if xy are initially combined using an OR operation, the 4 possible forms would look like this. Or maxterm x plus y, maxterm x prime plus y, maxterm x plus y prime, and maxterm x prime and y prime. In addition to that, each variable from either a minterm or a maxterm may be primed or unprimed depending on the bit of binary number. Refer to this table here. So for the minterms, if the corresponding bit of each variable is 0, then variable should be primed, and if corresponding bit is 1, the variable should be unprimed. In maxterms, on the other hand, if the corresponding bit is 0, the variable should be unprimed, and primed if the corresponding bit is 1. You may also notice here in the table that every minterm is designated a symbol, a small letter m, and a subscript which corresponds to 0, 1, 2, and so on. While in the maxterm, the symbol is a big letter M. It is also important to note that every maxterm is a complement of its corresponding minterm, and vice versa. For example, we have a minterm xyz. To get its corresponding maxterm, we should complement the whole term. And by complementing the term, each variable will be primed and the operation will change to an OR operation. Now that we have determined and understood what is a maxterm and a minterm, let's try to dig a little deeper. A Boolean function can be expressed in 2 forms, known as sum of minterms and product of maxterms. When we say sum of minterms, it is also known as sum of products or SOP. Basically, it is the sum of all minterms that defines a Boolean function that gives 1 as an output in the truth table. And sometimes, the form of sum of minterms is convenient to express a Boolean function. In simpler words, the sum of minterms is a function containing terms grouped together by an OR operation, and those terms contain single literals that are grouped together by an AND operation called as minterms. For better understanding, we have provided a truth table for minterms that would be utilized later on. We have here an example. When we look at the table, x prime y prime z is designated as m1 in minterm, x y prime z prime is m4, x y prime z is m5, x y z prime is m6, and x y z is m7. Thus, by expressing each term to its minterm form, the function is equal to f of x, y, and z is equal to the summation of 1, 4, 5, 6, 7, which is also known as the Boolean function in canonical form. Note that the term canonical form refers to the Boolean functions expressed as a sum of minterms or a product of maxterms. Now let's try to solve a little bit tricky example. Unlike the previous example, where the literals are complete in each term, what if the given Boolean function has some missing literals in some of its terms? How are we going to express it to its sum of minterms? For example, we have to express the Boolean function f equals to a plus b prime c to its sum of minterms form. As you can see, in the first term, both literals b and c are missing, while on the second term, the literal a is missing. Thus, we have to complete it first in order to express it to its sum of minterms. For the first term, in order to add b literal, we have to multiply a to b plus b prime by distributing it. Same process with the c literal. For the second term, since a is the only missing literal, we can just multiply b prime c to a plus a prime. After that, we shall combine the two terms. However, as you can observe, there are two a b prime c, and with the potence to theorem 1, wherein x plus x is equal to x, therefore we can just remove the other duplicate. Then rearrange all the terms in ascending order and obtain the sum of minterms. On the other hand, the product of max terms is simply the complement of function's sum of minterms. The product of max terms, also known as the product of sums or POS, is another alternative way of expressing a Boolean function that can also be written in pi notation using this product symbol. In order to obtain this form, we have to follow the two-step process. First, we have to find or identify those minterms that give 0 as an output in the truth table. And second, since POS is complement of SOP, we have to complement those minterms using De Morgan's law. Similar to SOP, we also have a truth table for POS. Applying this process, we have here an example of f is equal to x prime y prime z prime plus x prime y z prime plus x prime y z. First, we have to complement the whole function by applying De Morgan's law. Then, we distribute the complement to each term since they are not a single literal, as well as converting the OR operations into AND operations. After that, we now complement each term, reversing the primed or unprimed state of each variable in each term and converting AND operations into OR operations, and therefore obtaining the product of max terms form. For convenience, we can also write the product of max term form to its canonical form f of x, y, and z is equal to pi of 0 to 3.
We will now proceed to the conversion between canonical forms.
The canonical form of sum of minterms is also known for its fancy name as canonical disjunctive normal form or CDNF. Canonical means standardized and disjunctive means logical or union. Canonical SOP expression is represented by summation sign and minterms in braces for which the output is true. For example, we have here a given truth table of a function. In this table, 1 indicates the function is true in that term. Thus, this function is true for the minterms 1, 2, 3, and 5, or we can write it in this canonical SOP expression, which is represented by this summation sign and these minterms for which the output is true. On the other hand, the canonical form of product of max term is also known as the canonical conjunctive normal form or CCNF, and conjunctive means intersection. In this form, the max terms are ANDed together for which the output is false and was represented together with this pi symbol. Going back to the previous table, the zeros indicate that the function is false in that term. Therefore, we have the max term 0, 4, 6, and 7, or it can also be written in this canonical POS expression, where we have the pi symbol and the max terms for which the output is false. So generally speaking, in order to change from one canonical form to another, we interchange the summation and pi symbol together with all the numbers that are missing in the original form. From the table presented a while ago, we can also determine which terms are minterms or max terms just by looking at the column of the resulting function. The ones are minterms and the zeros are max terms. Further, the minterm with the subscript j is the complement of the max term with the same subscript j and vice versa. For another example, we have here a truth table for the function xy plus x prime z.
In the table, the function is true to those with output of 1s, which are the minterms, and false to zeros, which are the max terms. Therefore, we obtain the minterms 1, 3, 6, and 7, and max terms 0, 2, 4, and 5.
And once we express it to its canonical form, we have f of x, y, and z is equal to the summation of 1, 3, 6, and 7, which was the canonical form of sum of minterms. And in order to convert it to the canonical form of product of max terms, we have to complement it by interchanging the or, to, and operation and list the numbers which was not on the original list. Since 1, 3, 6, and 7 is the original list and there is only 8 numbers in the list, therefore we shall interchange it with 0, 2, 4, and 5 since they were those numbers that are not on the original list. And as a result, we obtained the f of x, y, and z, which is equal to the pi of 0, 2, 4, and 5, which was the canonical form of product of max terms.
Now that we have discussed the canonical forms representing Boolean functions for SOP and POS, let's continue to standard forms. Similar to the canonical form, both SOP and POS also have their standard forms. It reduces the number of inputs applied to logic gates as its primary benefit. In terms of standard SOP form or standard sum of products form, all the literals don't need to be contained to each product term. In other words, it is possible for the product terms to be minterms or not. Note that the product terms refers to the end terms of the Boolean expression that contains one or more literals, while sum refers to the ORing of these terms. Let's take this function as an example. As you can observe, there are 3 product terms. We have here 1, 2, and 3. The first product term contains 1 literal, which is y prime, 2 literals for the second product term, which is the xy, and 3 literals, which is the x prime y z prime for the third. These product terms are ORed together to get the sum. Thus, for its logic gate, this expression consists of several AND gates and a single OR gate, wherein each product term needs an AND gate except for the first product term since it only has 1 literal. In this figure, as you can see, both second and third product terms are the one that only has an AND gate, and all these product terms go through this OR gate. On the other hand, standard POS or standard product of sums form consists of some terms that does not need to contain all literals. Therefore, the sum terms may or may not also be the max terms. Also, note that sum terms refers to the OR terms of a Boolean expression which may contain any number of literals, and ANDing these terms is the product. For example, we have here an expression. In this example, there are three sum terms. The first sum term has only one literal, while the second and third sum terms have two and three literals that were ORed together, and these sum terms are ANDed together to obtain the product. For its logic gate, both second and third sum terms have an OR gate, while the first sum term hasn't since it only has one literal. Then all these three sum terms go through the AND gate to obtain the product. And that would be all for this tutorial video. We hope that you've learned something. Please don't forget to like and subscribe for more videos.